How do we really know if a new therapy heals depression or if a specific teaching method actually improves grades? We don't just guess, and we don't just observe relationships. We experiment. Welcome to the Villanueva Damo Academic Corner. I'm Jennifer Francia Villanueva Damo, and along with Hernie Peña Damo, we are diving deep into the gold standard of scientific inquiry, experimental research. Today, we are breaking down how to establish true cause and effect, and crucially, how to navigate the minefield of control problems that threaten to ruin your study. If you are serious about understanding how robust science is actually conducted, you are in the right place. Smash that like button right now to show you're ready for some rigorous learning, and let's get into it. We define experimental research as a systematic, scientific approach designed for one major purpose: determining cause and effect relationships. Unlike correlational studies, where we just sit back and watch how variables relate, here we actively intervene. We manipulate an independent variable, the thing we think is the cause, and observe its effect on the dependent variable, the outcome. We do this under tightly controlled conditions to ensure validity and reliability. This isn't just academic exercise. This is how we develop theories and policies in psychology, medicine, and the social sciences that actually impact the real world. To make these claims stick, your study needs two massive pillars to stand on, which we emphasize in all our work. First, randomization. You must assign participants to your experimental group and your control group without bias. This ensures that annoying potential confounding variables are distributed evenly. If you don't randomize, you don't know if your results are due to your intervention or just because one group was different to start with. Second is control. This is your ability to keep everything else constant. You use control groups that don't get the treatment and you match participants. Without adequate control, external factors sneak in and influence your findings, rendering your results misleading. Developing a truly controlled study design is tough. We see students struggle with this constantly. If you need help designing your own methodology, check out the link in the description below for our exclusive resource guide on structuring experimental designs. It's a toolkit we wish we had when starting out. Even with the best intentions, experimental research faces significant control problems. These are threats to your study's integrity. The biggest enemy? Confounding variables. These are extraneous factors that change right along with your independent variable. If you don't control them, you never know if your treatment caused the outcome, or if the confounder did. Then we have human elements. First, experimenter bias. This is when we, as researchers, unintentionally influence the outcome based on our own expectations. Maybe we smile more at the experimental group. The fix? Double-blind procedures where neither the participants nor the researchers know who is in which group. There is also participant bias. The famous Hawthorne effect shows us that people change their behavior simply because they know they are being watched. To combat this, we sometimes have to use ethical deception or placebo conditions so participants in the control group don't know they aren't getting the real treatment. The list of threats continues. We have to watch out for demand characteristics, where participants guess the study V's purpose and try to help or hinder the results. We use single-blind designs to prevent this. We also face selection bias if our groups aren't representative. We face maturation effects in long studies. People just naturally grow or change over time, regardless of your experiment. We face mortality or attrition, people dropping out of the study, which ruins your carefully balanced groups. And finally, there is the issue of external validity. Even if your study is perfect inside the lab, high internal validity, does it actually apply to the real world outside the lab? We need diverse samples in real-world settings to ensure it does. So how do we, as researchers, fight back against these control problems? We run pilot studies, first small trial runs, to catch these issues early. We also lean on technology. We use automated data collection and AI-driven analysis to minimize human error. We are even seeing the rise of virtual reality experiments, which offer incredible control over environmental variables that is impossible in the real world. Of course, we must always balance control with ethics. We are constrained by informed consent and participant welfare, which sometimes limits how much we can manipulate variables. Experimental research is a powerful tool for scientific discovery, but it is not easy. It requires rigorous design, statistical precision, and constant vigilance against control problems like bias and confounding variables. When you overcome these challenges through careful planning using randomization, And proper controls you produce reliable results that meaningfully contribute to our body of knowledge. If you found this deep dive into research methodology helpful, make sure you subscribe to the channel so you don't miss our upcoming videos on statistical analysis. And do not forget to check out that resource guide in the description to help you design your next study. Keep questioning, keep controlling your variables, and keep researching. We'll see you in the next video.